5th power. So in order to get rid of the 1/5, we're going to raise both sides to the 5th power. So here 5, and then here to the 5th power. So remember, we had another example similar to this, where there's an outside number. So the 2 right here has to be raised to the 5th power. So 2 to the 5th power is 32. And then 1/5 to the 5th is 1, so this leaves us with x minus 1. On the right side, 1/5 to the 5th power is again 1, so that leaves us with 2x minus 17. So we distribute the 32. Don't forget to distribute it here. And so minus 17, we subtract 2x from both sides, and we add 32 to both sides. Okay, so that gives you 30x, cancels there, equals 15. Divide by 30, and so x is 1/2.
I'm not going to get 500.
Okay, for number 17, they give you the formula for the skid length of tires on the ground. So S is the length of the skid marks, and then F is the coefficient of friction, and let's see, N is, what else? The percent braking efficiency as a decimal. And so you have to figure out what D is in this problem. So we know that, let's see, it says, was a car going above the speed limit of 60 miles per hour when the skid began? So the S is the speed, so we're going to replace S with 60. And then 30. F is the coefficient of friction, which is 7/10, so 0.7. D is the one we're solving for. And N is the braking efficiency in decimal. So they tell you that it's 60%. So 60% is a decimal. You move it 2 places to the left, so it's 0.6. Okay, so you take a calculator to multiply these 3 numbers together. So 60 equals, so when you multiply those 3 numbers, you get 12.6, and then there's D, and remember it's inside a square root. So we want to get to the value of D. So we square both sides, and this is 3600 on the left side. On the right side is 12.6 D. Divide by 12.6 on both sides. Cancels here. So that gives you D equals approximately 285.7, or approximately 286. And so it says that, let me see, get the problem here. The car skidded 250 feet. Okay, and here we got that for the situation under which a car was running, the skid mark would, if it was going above 60 for 60 miles an hour, the skid mark would be 286. Well, the actual skid mark was 250 feet, so this means that the car was not speeding. Okay, because this 286 is less than 250. So car was not speeding. Alright, for 19, we're going to estimate the age of a buck if we know the length of its, let's see, the length of its antlers. So L is the length of the antlers, and T is the age in years of the deer buck. So this particular one has antlers that are 36 inches long. And this is 9 cube root of T. We're looking for T, right? We're looking for the age of it. So I have to isolate the radical first. So that gives me 21 equals 9 times the cube root of T, because that's a 0 now. And then, so now I divide by 9. So That gives me, if I reduce it, I get 7/3 equals cube root of t. So now I'm going to cube both sides, and so that gives you, again, put it into a calculator, right? So you could, on the left side you get, on the right side you get t, and you put 7/3 to the third power on a calculator, you get approximately 12.7. So this buck is around 13 years old. Alright, so for 21, they want you to state how many solutions there are, how many real solutions. So for the first one, you would have to take, there's no, the square root of a number is not negative. So for the first one is no solution. Okay, no solution because of the negative on the in front of the 5. Okay. For B, you move the 6 over and move the 6 here, and it becomes positive 5. When you take this, when you square both sides, you have x by itself, so then that's going to give you one solution for this one. For C, you divide by -2 on both sides, and that gives you -2. You cube both sides, and x will be by itself, and so that's also going to give you one solution. For D, you square both sides. When you square 0, you get 0. You move the 40 over, and that gives you one solution. And then for E, you cube both sides, and even you could cube a negative. There's no problem with that. So that's one solution.